Thank you very much. And it's really great to be back at SREcon. I said it before, but it always feels like coming home. I started my career in reliability engineering and software exactly 10 years ago. And 10 years ago is also when there was the first SREcon, 2014 in Santa Clara. So we are really looking back at a decade of progress in SRE now. And I had my first SREcon here in Dublin in 2015, which is also where I for the first time met the Zalando folks that the company I work for here. Back in the day, I tried to sell to them. Now I'm on the other side. Yeah, but for this talk, I really asked myself, what kind of talk would I like to listen to at such an event where we are kind of at this, at this time? And so I came up with this. So it's basically, it will have two parts, which will be like looking back at the past 10 years, and it's kind of looking forward to the next 5 to 10 years and see what's coming there. Just a short bio slide. I'm Heinrich. I'm working at a company called Zalando. Many of you will know it. It's a large fashion platform in Europe. We have around 3,500 software engineers and actually more microservices than software engineers by quite some margin, which is interesting. We also have a ton of Kubernetes clusters. There are also reasons for that that are like, you can argue about them, but it's a fairly sizable and complex environment. And I was leading the SRE group there for about 2.5 years after I escaped again, and now a senior principal engineer still look at the global reliability environment at Zalando and what we're doing across the company. Before that, I worked for a monitoring vendor called Seconus, which built one of the first metric SaaS platforms, and I was a chief data scientist for them. All right. I already alluded to the menu, so it will be again a night and like miracle-themed AI-inspired slide deck, like we just saw from Daria. So first looking back, then talking a little bit about the principles, and then looking at 3 frontiers. What have we achieved? So the first thing that comes to mind is really hardware provisioning and capacity planning. So back in 2014, we were rocking hardware. We had our data centers, actually just one rack with a bunch of machines. And we were running this interesting operating system, OmniOS, where you could provision zones, and you would ask a sysadmin to give you a zone to do dev stuff, and you would ask them to give you a zone to do your prod stuff. And then you would install packages on them with PKG or Yum later on. And yeah, so that was basically the flow. And today we are in a completely different environment. We have different tools. But yeah, the big difference for me is really, do you have to care as a team about the hardware you're running on? Do you have to care about like how much hardware you are actually buying? And back in the day also, like capacity planning and how much machine do you need in the next year was a big topic. Like that was a common request, like forecasting over year to year how many RPS we are doing, so we are knowing like how much machines to buy. And spinning them up and getting them to production, sometimes it really took up to a month until we had like a finished service and it was really running in a production environment. Today, with infrastructure as code, we are deployed on AWS and have Kubernetes. It's like a YAML file you can push quite easily and fast. The second bit, I already talked a little bit about like Yum and SSH were the ways that we deployed our packages. And for me, Docker is really a revolution that happened. Just being able to get a clean environment on your local machine that is pristine is quite significant. In 2014, that didn't exist. You had your local machine, and then you installed some packages, and everybody that had used Python on local machines knows what a mess kind of local environments are if you just have one local environment. And Vagrant came, I think, around that time as well, which made things a little bit better. But we are in such a great world because we have this fast and universal packaging now that allows you to spin up these pristine environments very quickly. Also, installing software on your local machine is so much easier since we have like Docker as a packaging technology. Monitoring, 2014. I think Nagios, Graphite, Ganglia, the people that have been around, lots of interesting memories. I think we had solutions for a lot of things back in the day when it comes to just recording metrics, but it wasn't standardized and was kind of a mess. And out-of-the-box functionality was quite limited. So you just got a bare bones system. 2024, we have somebody won, right? Prometheus won, Grafana won, everybody uses it. And what I really want to highlight here as well is how well the community and the out-of-the-box value of these products work. We have the node exporter, we have standard exporters that we install everywhere. And then I also have the community maintained dashboards. So getting from 0 to having base level monitoring is actually very quick. And the second very big standardization effort that happened in this space is OpenTelemetry. So back in the day, you had all kinds of vendor-specific SDKs and libraries you were integrating to your services if you wanted to export telemetry. And today, thankfully, we have the one standard that everybody converged on. Now let's talk about observability. And there are many, many names or meanings that the term is loaded with. But I want to specifically want this to be understood in the sense of cross-application debugging. So if you are operating microservices or just a larger environment, really understanding problems across application boundaries becomes incredibly important. And it's extremely hard to do with just monitoring tools like logs and metrics. And you will play the game of, is my dashboard green, is your dashboard green, or you're grabbing through log files and trying to figure out how a request was making it through a larger ecosystem. And there were two companies in 2014 that had sophisticated systems that were able to have true observability and cross-application, cross-team debugging. And that were Google and Facebook, who are also, I think, one of the long-term diamond and gold sponsors of this conference that also bootstrapped. I mean, Google obviously pioneered the SRE name. And yeah, Google had Dapper internally, and they made the paper available also around that time. And there was a similar system, Scuba, at Facebook, which aimed at these things. And in 2024, we have actually spin-offs of those two systems, which are commercially available on the market. So Ben Ziegelman, who co-wrote the Dapper paper, founded Lightstep, which got bought by ServiceNow a while ago and is now called ServiceNow Cloud Observability. And then we have Charity Mayers, who has a Facebook background and founded Honeycomb, which is also a very powerful cross-application, debugging tool. And I think the number of observability vendors has substantially grown. But for me, it's kind of these two companies really get observability and understand how it's best, how to best get most value out of it. We are a ServiceNow customer, and this is how our tracing looks actually for the Zalando front page. So if you go to the Zalando homepage, every request that the user makes is creating a ton of spans. This is a typical one, which has around 250 spans, which are sitting below a single HTTP request. And it can be up to 1,000 if we are looking at different endpoints that are a little bit more like microservices in the back. So the investment we made into this is quite significant and goes back about 5 years by this point. And we are at an extremely happy place with our use of tracing and our effectiveness to debugging with tracing. It goes to such a degree that I would say this cross-team and cross-application visibility and debugging problem is actually solved for us. We can usually just tell, okay, which service is at fault, look for the red. It's where the red things is, where the errors are, then you can understand which application has it, you understand who to page because you know who owns the application. This part we even automated, so we drive our alerts from tracing data to a large degree. And then you also have telemetry like log entries that are relevant in the span context directly attached. So your debugging journey from, okay, something broke in the user experience to, okay, this team and this microservice had a fault that has been solved to a large degree with this tracing investment. And the other nice thing you get with this tracing-based observabilities is metrics and SLOs, which you can directly drive from tracing data. So most of our SLOs and dashboards like that monitor APIs are really derived from this tracing investment, and we can do request errors and duration, again, directly from tracing. Okay, let's talk a little bit about principles. So we have seen 3-4 different areas where we made improvements. And I wanted to take a step back and just talk about reliability engineering as a field and a profession. So to give us an idea, like in which areas did we make improvement, and maybe potentially also have ideas where we are, have still room to grow. So when I took over the SRE organization at Zalando, I regarded this as my quest. This is the Zalando service graph from 2019. And it has this nice like Death Star architecture, right? It's a mess, right? You cannot really reason about this well. And I thought, okay, this is a complex beast. How the hell should we make this reliable? And how to figure this out? And I figured out this is actually not the greatest question. A much better question that I should ask myself is, how do I make this reliable? Which is our beautiful website. And like one of the key learnings for me is that the systems are not that important. It's actually the user experience that is much more important. And that simplifies a lot of things, because this page is relatively organized and I can pinpoint functionality that is on the side, like browsing the catalog, viewing product details, and viewing the cart. So the systems that are directly supporting that user experience, those are the systems I really care about. And probably there are like 65 to 80% of the 4,000 microservices that we have that are not related to this, so I don't really care about them. And yeah, so there is I think a story I heard a long time ago. I think it was a business executive who said, like, I don't care if your data center is on fire, as long as the customers are happy. And I think there is a lot of truth to this. Don't protect the machines. If the machine has an itch, a high CPU, or some memory problems, look at this during the business hours. Yeah? We have the Slack alerts for this, so people can kind of figure this out when they are working, but only page and interrupt people if there is a user experience problem. And yeah, so although probably I want to be alerted if my data center is on fire, I think the larger point stands that the users are the important thing. Let the architecture be complex, let the systems be broken, orient yourself towards the user experience. And the second key learning for me that is still for me a little bit hard to bear, I'm a mathematician and engineer by background, so if I can just code assembly and think about performance problems, I would be extremely happy. But the reality is, if you want to drive reliability in a large organization, it's actually a lot about people and communication, and then actually at least as much as it is about technology. And also a sad reality is the larger the company gets, the more it's actually about people and communication. And the challenges are much more in communication, upskilling, and driving processes than it is about technology. In a small company, it's really, okay, you're making your first steps, you're building alerts and dashboards, and that gives you good reliability. In a medium-sized company, the knowledge-sharing stuff starts to kick in. You have to organize your knowledge around mitigation of incidents. It's the playbooks. You want to write postmortems that you can socialize the learnings from incidents, and that's something that you start investing in, along with observability, which I would put to the technical bucket. And then finally, with very large organizations, you want to run weekly operational review meetings, so that's this WARM acronym I put on the slide, and do risk management. Like, who is excited about risk management, right? But that's, in the end, what really helps you, for example, to safeguard the Cyber Week event, the big load spike that we get. So instead of looking at this as a big death ball of complexity, the best model that I have is it's a three-layered system. You have the management at the top, which gives the whole thing structure and gives you people to talk to. Then the engineering teams that are actually doing the work are in the middle, which have a pretty tight coupling to the applications. So yeah, you're working with the teams together on those applications. And then lastly, you have the platform. And if you look at the advances that we made in the industry, there are some things, what's always good if you can go down in this diagram. So you want to go from something you derive through management to a team capability that the teams are doing on their own. And then you want to have team capabilities, so it becomes a platform capability. And if you are talking about hardware provisioning, for example, this is something that is now a self-serviceable platform capability. That's no longer something that teams need to do. And also our capacity planning is done by a central team. For us, the cloud is not so elastic because we have around 30,000, 40,000 nodes we need in Frankfurt. So you cannot just dynamically upscale. You still need to tell AWS exactly how many nodes you need. But it's something a central team can do. And then lastly, reliability engineering is always about feedback loops. And here are like some of the software delivery feedback loops that we have. So that are driving reliability. So the tightest feedback loop is maybe your linter when you are typing code that gives you immediate feedback. Then you have a cascade of maybe the compiler providing feedback, test providing feedback, CI providing feedback. And then in blue, we're hitting production with the deployment, the monitoring, the alerting. So that's typically the area we are most concerned with. And the name of the game is always speed is safety or speed is reliability. So we want to make this feedback loops a lot faster, or ideally we want to move stuff further in. So my favorite example is here when I hosted my first workback blog, I had 0 observability or testing around it, right? So if it went down, which it regularly did, I learned from friends sending me hateful emails saying, hey, okay, why is this down again? So we were relying on the outermost thing. And ideally, I mean, obviously you just type something and then, hey, okay, I immediately have this feedback. So it's all about making things think faster. And I just put some pointers to the advancements that we make. I think there's a lot about making this feedback loop faster over the past years that we were successful in doing. The incident process is kind of a meta feedback loop that sits on top of this blue production feedback loop. So we are actually, with the incident process, trying to make this feedback loop more effective and hopefully avoid a few iterations that we have to do. But it's also fundamentally a feedback loop. We have an incident, we write a postmortem for it, we may do a review, we derive action items, and then we implement improvements that hopefully reducing the impact of those incidents. All right, with a map in front of us, let's talk about the things that we may want to tackle in the next 5 to 10 years. And what I put here is really the stuff we're currently facing at Zalando, the things that I'm currently seeing and that we have started to invest in. And the first one is managing for reliability. So that's something that is overlooked, but it falls into a theme of reliability being actually a managerial problem as much, or a people and communication problem as much as it is a technical problem. So the question here is, how do we enable our management to steer for reliability? So as a central team, we will actually not make a lot of the decisions, but we will, and we cannot really drive reliability at the top. We have to enable others to drive reliability. And basically maybe the mantra of management that that is at least popular, and I think it's quite fitting, is always, you get what you inspect. So as a manager, it's very important to surface the things that you want to control and you want to work well. And so an innovation that we introduced at the company, I think 2.5, 3 years ago, is the so-called reliability report. That's a small, nifty piece of technology. It's a Python script. It's a few hundred lines of code long, which is auto-generating a Google Doc with all the reliability data that we collect through our systems. So it has tables, I will show them, about incidents, SLOs, on-call health, open postmortems, and the list is growing. And the report kind of looks not particularly pretty, but it's effective for various reasons. And I think the most important one is that it's not just a report, it's a report and a meeting. So we are doing weekly operational reviews on all team levels or on various levels across the business on those reports. And those reports have to be Google Docs because the meetings are always run with Google Docs. Our company has a culture to run meetings from Google Docs. So people would, before the meeting or inside the meeting, spend like 10 minutes to read the document and comment on it. And the discussion would be like driven by those comments. And just to give you a feel like how this looks in more detail, so this is an incident table, a little redacted. So we put the basic meta information around it, impact metrics, and then we have this take action column. And the take action is where the reporting happens. So teams or heads or directors are filling this out every week to give us a high-level overview what happened. And we sit there with the CTO every Wednesday morning, and my colleague Torbi here is sitting in the third row. He's kind of the master of that meeting, and we are reviewing all the incidents that happened on a really high level and be able to pick up patterns that we want to centrally address. SLO views, we strive to build out SLOs across our user experiences. So the little arrows that I put to the shop functions on the second slide, those are actually labels for SLOs. We have one on place order, we have one on view card, on view catalog. And the idea is that we map the entire user experience or business value chains with SLOs. And then if you scroll down the table, we basically get a top-down view on health. The incident table, it's a little bit, we call that Twitter-driven development. It's kind of what screams at you at the latest and the loudest. Whereas this table is really telling you, are we green? Is everything fine, user experience-wise? And we do SLOs on like a 28-day and a 7-day cadence, also appropriately for the meeting. And yeah, if it's red, we kind of ask people to report and say, hey, what happened and what do you want to do about it? And the last table, I'm pretty proud of that we do this. It's our on-call health table. Although Daria rightly pointed out that looking at the number of pages may not be enough to really understand how healthy your on-call schedule is, but I think it's a fairly good start. So we have that table that basically for every row is an on-call rotation, so that would be one on-call responder who was on call for that week, and for every weekday we see how many times they got interrupted. And you get a good feel like how many interruptions that really were. And then we put a magic number then 10, which is like, at that point it's red, and at that point management really has to report. So we use that reporting loop again, and then basically your manager or your director is explaining to the CTO why that person got woken up like 10 times that week and what you want to do about it. So it helps. Just the reporting, just putting the flashlight on it already helps. And then you can also appropriately discuss it and steer it in the meeting if you think that's necessary. So to put back another like feedback loop here, you can also see this warm meetings as kind of a feedback loop who helps the feedback loop that drives the feedback loop. So you kind of get an idea where this is going. And it's not the only feedback loop we had at Zalando. So don't really read that slide. But one of the things that I just wanted to highlight is we are actually, as reliability engineers in a large company, engineering these processes. So that's kind of our incident process together with the risk process, together with the weekly operational review meeting process. And this is actually the machine in the end that drives reliability at Zalando. So for me, the quest for managing reliability in the next 10 years is basically putting more of an emphasis on how these socio-technological systems are evolving. Maybe we see more of systems engineering in the sense of Donella Meadows. This is the book I put in there, which is kind of a more abstract framework, and apply that to reliability. We for sure will continue with these reports and enhance their capability. And we also want to be better at driving cross-organizational reliability interventions. So we figured something out that happened in 5 business units. How can we action and fix this? And that's something that we call the SRE champions model, kind of a community cross-organizational approach to this. And lastly, in the spirit of like accelerating those feedback loops, I think if you think about AI in the SRE space, really post-mortem and incident management is the thing that comes to mind first. And I just wanted to give a small shout out to Aptable, which is a vendor which has an interesting product or ideas in that space. Second frontier, mobile. So why is mobile important? And I brought you actually 2 stories here. The first one is the undetected order drop. So here, what happened, we got an alert, like view card had a slightly elevated error rate, like 13, 14%. And when the on-call engineer looked at their dashboards, they realized, wow, the shop is burning, essentially. The orders were down, I think, 50, 30%. And not just now, but they had been for a good hour. And the debugging took a while, but in the end, we figured out that no errors were thrown on our side. The traffic just disappeared before we saw it in our Death Star. And what happened was that our edge protection mislabeled a lot of our legitimate traffic as bot traffic and filtered it out. So we didn't see it, and there were no errors, so there were no alerts. So usually we have an order drop alert for this, but again, the engineer that was creating that and maintaining that order drop alert was on vacation. And there was a code change that changed the telemetry on those signals that we were hooking into. And so we were running without auto drop protection for a while. Needless to say, that changed afterwards, but that was a really, really interesting incident. And if we had the war meeting on next Wednesday, this is how our SLOs look like. Everything was green, right? There was no error. We never had an error. We didn't like that. And the second story is about the lurking add-to-cart failure. So when we, for the first time, added tracing to the mobile clients, we always observed an error rate for add to cart on certain Android version that was between like 10 and 30%. And that's interesting. I wonder what that is. But we just looked at the telemetry for the first time, so it wasn't really clear is it a measurement error or not, and it was quite noisy, so it was a ticket that somebody looked at, but it was kind of inconclusive. And then a while back, we made a change to our code, and that error rate dropped to 3%. And that change gave us a hint. We were actually injecting errors to all our HTTP requests from the mobile client that was labeling stuff as bot traffic. And our edge protection layer was pretty observant and filtered out that about like 30–40% of the time. So the root cause was then fixed, and it turned out it was not a permanent failure. If you retried, you kind of got along, but it was a little knack that we caused for a lot of our users. And we didn't like that either. So the question that this really triggers for me is this even the right picture? And the answer is it's really not. We missed about 50 million devices that we don't have in this architecture diagram. And an edge protection, which is quite important if you really want to reason about this as well. So in order to really protect the user experience, because remember, this is what we really want. We want to protect the user experience. We need to look at this whole thing. We cannot just stop here. And what are the challenges involved with moving to mobile observability and improving the situation? The biggest challenge by far is the glacial deployment speed you have with Android and iOS releases. They are App Store reviews. We deploy every other week, and we are fast. But even if we have made a release, it takes 4 weeks until we reach 80% penetration. So, I mean, talk about continuous delivery in that environment. It's like 4 weeks until a delivery is really out at the users. So it's a very, very different engineering mindset, almost like engineering desktop software that you have as a mobile engineer. On top of this, fragmented platforms, network, legal constraints, quite significant. You need consent for a lot of things. Automated testing of UI, like it's a pain, so it's not really happening. And yeah, then you don't have a lot of telemetry. So this is kind of the space we are operating in. It's a very challenging space, or in other words, there's tons of opportunity to do better. And for us, it's really, we want to push distributed tracing. As you already saw, we are quite heavily invested into distributed tracing, and we want to expand the coverage. We already built an SDK for the browser, which is OpenTelemetry based and works nice, and we expanding that to the mobile client. And actually pushing some of the SLO measurements already to the clients. So for example, place order, the order drop, we now are able to detect this by the errors we see from the mobile client. And the mobile observability with distributed tracing has a quite compelling target picture if you think the end game through. So how could it look like? And this is a picture of this. So the green stuff is the thing we already have. That's the 200, 2,000 spans we are collecting from the Death Star. What you want is actually like start the traces earlier and move it towards the edge to the client, and then maybe even do something a little more with more longevity around the user session. So imagine you had data like this. What could you all see? So you could detect problems on the edge. You could detect retry behavior. This place order failed, but the next place order actually worked. A 50% error rate that is fatal is death for the company business. A 50% error rate that you just can retry is actually not that much of an issue. You can understand network latency for the first time. Your user experience is the latency that you measure in your application had nothing to do with the latency your user is actually experiencing when they are on their mobile device. And you are able to see that difference. And you can also nicely tie in like rendering performance signals you may be having in completely different systems if you had like end-to-end tracing support for mobile. Yeah, so I listed some of the benefits that I just described here. So once we have full coverage of tracing, and I also want to give a shout out to a vendor here, which helped make me understand this vision a lot better, which is Embrace.io. And they are working to make something like that happen. Okay. And the third and last frontier is data operations. And I also want to start this with an incident story. And that's the famous Euro incident from 2022. So what happened here is we got alerted on a slightly increasing order drop. So we're seeing less and less orders coming through against the data we would expect. And yeah, we looked at the errors, and there was a currency, invalid currency that we were seeing in the checkout. And the currency was called Euro. It shouldn't be Euro. It should be EUR. We don't know what a Euro is. And then we traced that back and looked into where did this come from? Where did that happen? And we had to go like back and back, and ultimately it turned out that this was yeah, a data record in our product offer pipeline. So if a multi-stage, and maybe let me show that slide first. The way the offer service works is we get like product, stock, and price data from all kinds of backends and partners. And then we have multi-stage data pipelines that transform this into an offer. And then the offers get produced, get put onto a data bus, and then they get picked up, they get indexed, and the catalog is driven from them, but they are all asynchronous systems. And it took us a little while until we figured out like which system was at fault that produced that illegal record that in the end made our systems choke. And that was a record that looked like this. So somewhere in the data we had an illegal attribute. And it took us actually a while to detect it, just because after the bad deployment, the impact was not immediate. And then it also took us a while to mitigate it. So we roll back the service, and then nothing is actually fixed. Actually, as a matter of fact, it continues to get worse, because you have all that data, it's still sitting in the queue and still like populating the indices. So you drain this, and what you then have to do is a complete refeed of the catalog. So re-ingesting like hundreds of thousands of catalog items, put it through the data pipes, and then like re-indexing them until they are properly fixed. So that took about 3.5 hours, and it was one of the most like costly events for Zalando in 2022. So highlights here again, just a long delay between cause and impact, very long delay between fix and the mitigation. And then also the telemetry we had was essentially useless. Throughput, backlog, latency, no problem with those. All the dashboards perfectly green. Tracing, we saw the error that was thrown in there, but we didn't know which system it was. So usually the good thing about tracing is it directly points you towards the failing system. So we had none of this. And the thought experiment that I wanted to show you here is how would this incident have looked like if this was a REST architecture? So say we had an offer service that just gives you back an offer or a list of offers based on the product service, stock service, and price service. So you are synchronously calling through all of this. You make the bad deployment, immediately have the feedback. And you may see a trace like that shows you, hey, the show offer is not really working. We have an illegal currency. And you trace it back, you see the whole causality chain, you see what is potentially contributing to that error, and you can pretty soon tell, well, it's the offer service that is the culprit. And with that, you can like catch this very likely before it becomes actually a problem. So the significance of data is growing, not just in this business process that I just showed you. It's incredibly important for AI. If you want to train an AI system, you need proper data, and it's very important for business intelligence, since the top-level management reports are all driven by data. And we actually improved our incident process to handle better to data incidents. Data incidents, like illegal data that is somewhere, doesn't really have immediate user-facing impact, so people usually don't write a postmortem for them. So we changed the guidelines to get more data about this, and this is kind of a word cloud about the most significant like data-related incident patterns that we saw. what are we doing to counteract this as mitigations, and what ideas are we following? So the first one is data contracts. We want to go not at the very end of a value chain and understand, hey, okay, our checkout broke. We want to move that quality checks earlier up the chain. And the idea here, or the tool and the term that is floated is data contracts. So we are trying to move those measurements further upstream and check the expectations from the customer earlier in the chain. We have invested in data SLOs. This is something that we are proactively doing, and that is useful for a number of applications, but primarily the most value we are getting out of this is for data pipelines. So they're business processes that are driven by multi-step data pipelines. So basically, you're comparing all the events at the beginning to all the successful completions of the run. There are some subtleties here. You cannot just use the counts, so you need some processing step in the middle, but it's conceptually relatively straightforward. And the third one, and this is really a big one, is data lineage. In tracing, you always understand end-to-end where your spans are. In data, you have no idea. In the worst case, just somebody SCP'd a CSV file somewhere, and that was your integration. So you need to understand this better. And yeah, there's open lineage community approach that is seeking to standardize this, and we have an internal experiment that I showed that is built with a process mining tool, so different domain, but for the specific application, we had some small successes with this. And lastly, I just want to share a little bit of a wild hypothesis, or a certain angle on this problem with you. Actually, if you look at the integrations between data systems, they are relatively simple, right? You have a system A and a system B, and you are pasting messages, bytes or messages between them in one direction. And that reminded me actually of the first networks programming experiences that I had in the early 2000s. I was rocking Perl, I was having the big learning Perl book, and I thought I'm doing internet programming, providing a little card game server, and I was opening TCP pipes and sending messages. That is actually what we are doing here to some degree. We are passing messages across pipes. And much later, I realized, wow, engineering HTTP APIs is so much easier. You're just you're no longer worrying about keeping a connection open and keeping the pipes open, and you get immediate feedback on all of this. So what we actually learned is not to use TCP pipes, but to actually use HTTP pipes. And those look a little bit like it, but they have some very meaningful differences. First, the pipes are never one-directional. They are always bidirectional. You get something back. You're not just sending bytes. You are sending metadata, like a get header and so on. You know what an error is. And then lastly, even if you have REST integration, this is not enough. Really, to operate a large-scale REST architecture, you need the tracing backend. So my kind of wild speculation is that we need to rethink the integrations in the data landscape, and we need to be willing to try some insane things. And tracing took a long way to materialize because just the level of insanity is pretty high. The data volume is insane, and the level of work you need to do is insane. So that's it. I hope you got some inspiration and from food for thought for the next 5 years. I'm really excited to see what we as a community will be doing here in 5 years and what talks we will see, specifically watching at these three domains. Thank you very much.